Good day everyone, welcome back to my channel. Today we are looking at number patterns. In this exercise we will be filling in the next three numbers in the pattern. Suppose you are to find the values of the following term. Okay, so let's say now we have 3, 6, 9, 12, missing number, missing number, missing number. Now, if you are to find the values, or rather the missing values in this term or the sequence, the first thing we need to be able to identify here is that this sequence is arithmetic. Now, what does it mean when you say this sequence is arithmetic? We need to be able to identify that this follows a linear sequence, which is, or rather follows the sequence of y is equals to mx plus c. All of these, or rather sequence that follows this application of y is equals to mx plus c, are all known as linear patterns or straight lines. Notice this word here, straight lines. These are straight lines. All of these are straight lines. But I'll explain that in other videos later on regarding straight lines and patterns. Now, to be able to find the other missing values, we need to first identify some key conceptions regarding two number patterns. The first thing that you need to establish here is to be able to identify or denote that this is term 1, this second value here is term 2, second term, this is the third term, term 3, this is the fourth term, the missing value is term 5, other missing value is term 6, and the last missing value is term 7. That is key in our understanding of finding the missing value. Now, essentially what one would actually often do is to establish first the common difference in the sequence of this pattern. We know that D for difference is equals to term 2 minus term 1 is equals to term 3 minus term 2. Now, to find a common difference, we need to be able to substitute the correlevant values within this these terms. In this case, we have term 2. We know that term 2 is equals to 6 minus term 1, which is 3 in this case, is equals to term 3 is 9 minus term 2 is equals to 6. The common difference, let's maintain the D as a term common difference to denote the common difference. And then we know that 6 minus 3 gives us 3, should be equals to now in this case, and it should be equal on either side of the equal sign. So 9 subtract 6 is equals to 3. When you notice that this has allowed us to find a common difference on both sides, so this is what we were looking for essentially, D as being the common difference. Now that we found D, we need to identify what A is. So A is equals to the first term in the sequence on this this pattern is actually 3. Now we know what A is, so our first term. Now we should first now start establishing, rather than even not establishing, but identifying or agreeing on certain key conceptions with regards to number patterns. First of all, T. We should agree that T1, term 1 is equals to A. And term 1 in this case, A being is equals to 3. And we should agree with that. And then we have term 2. Term 2 is equals to A plus D. To substitute this further, we know that A, this value here, is equals to 3. A is 3 plus our difference, this value here, is equals to 3. Still remember we're looking for term 2. Let's just maintain this denotation. 3 plus 3 gives us 6. And term 2 now, you can clearly see that it's actually indeed 6. Moving forward, let's look at the next value. Let's find term 3. Term 3 is equals to A plus 2D. We should agree first with this conception. Let's substitute to derive and or to our answer. So A in this case is 3 plus 2 times, what is our difference? Our difference in this case, we saw that it was 3. Now 3 plus 2 times 3 gives us 6. Let's maintain what you want to find. In this case is term 3. We want to find term 3. We want to find term 3. 6 plus 3 gives us 9. And we can clearly say term 3 is equals to 9. Now, we should now therefore, because now it looks like this is going to be consistent right across, we can now start concluding on the basis of what we find, or evidence of what we observe in this case, to say that therefore, let me just devise a table here, a portion here, so that you can be able to work systematically with the space. Therefore, we can now start saying that therefore Tn is equals to A plus, open bracket, n minus 1 multiplied by the difference. This is what it means essentially, because we will find this being arithmetic, or rather linear in this sequence, in this case. Now Tn is equals to A. We know that A, we saw that A is 3 plus, open bracket, n, we don't know what n is in this case, minus 1, and the difference, we know that the difference was, or we found the difference to be 3. Now multiplying this into the equation, we know that 3 plus 3 times n gives us 3n, positive 3 multiplied by negative 1 gives us negative 3. Maintaining this, we know that 3n, and we just actually write this out in the right format. 3n and 3 will cancel out these two values here. 3 subtract 3 is equals to 0, so we leave it out. So technically what this means now, or rather essentially what this implies, that our pattern follows the pattern of 3n, or rather 3 multiplied by any value. Now let's go ahead and test this claim. To test this claim, we need to look at, or rather test and look at other values in this composition. Let me use a ruler to be able to test and verify this. So I'm just going to have to erase this part here. Now, we saw that Tn is equals to 3n. Now, to find term 5, let's say term 5, the missing value, the first missing value, it means that 3 times, in this case, term 5 is the fifth term, rather. 3 times 5 gives us 15. So what it means now is that this value here is equals to 15. Moving on forward, term 6 is equals to 3 times 6. 3 times 6 gives us 18, which means this value here is 18. Let's look at the last term. Term 7 is equals to 3 times 7. 3 times 7 gives us 21. That's our final answer. That is 21. So term 7 is equals to 21. So we're done with the first example. Let's look at other examples relating to patterns. Okay, now suppose now you are given another set of numbers. Okay, let's look at the second one. It was A. Let's look at B. B, in this case, we have 4. We have 9. We have 14. We have 19. And we have other missing values. Now, the first term in this case is term 1. Second value is term 2. Third value is term 3. Next value is term 4. Next value is term 5. Next value is term 6. Next value is term 7. So now we clearly see that this is also up, or rather this appears to be linear. Now, first of all, like I said earlier on, the first application is to find the difference, a common difference. To find a common difference, you write D is equals to term 2 minus term 1 should be equals to. If it's not equals to this first set here, it will be wrong. So now the set must be equals to the set here. So we have term 3 is equals to, subtract term 2. That's how you find the common difference. In this case, now we have term 2, which is 9, minus term 1 in this case is 4, is equals to, or rather should be equals to, term 3 is 14, minus term 2 is equals to 9. Now I want to find what the common difference is. In this case, clearly know that when we have 9 subtract 4, we should definitely be getting 5 in this case. Is equals to 14 subtract 9, get 5 as well. So because of that answer that we found on either side, we are actually just looking for one composition in this case. The common difference in this case is just simply that. So D is equals to 5. Now that we found the difference, the next thing that we need to find is A. A is the first term in our pattern. We know that A now in this case is 4. Now, following our rule, Tn is equals to A plus open bracket n minus 1 multiplied by the difference. A in this case we have 4 plus n minus 1. The common difference is 5. Okay, 5 times 5 n in this case we have 5n, and 5 multiplied by negative 1 gives us negative 5. Now moving on forward, just devise another table here, another border just to demarcate the calculations. So now Tn, just maintain Tn. I'll use a different color in this case, which is continuing from here. So I'm calculating now the actual formula, or general formula in this case. So writing it out in algebraic form, or in an orderly form, it will be 5n. So now we know that 4 minus 5 gives us negative 1. So Tn is equals to 5n minus 1. Now, to find missing terms now, rather, yes, the missing terms in this case. For instance, we want to find term 5. It will be 5 times 5 minus 1. Okay, now to find our value, now we know that 5 times 5 is 25 minus 1 is equals to 24. So which means essentially term 5 is equals to 24. So we can go ahead and write it down. So our fifth term is 24. And that's what we found here. Let's move on to the next value. We know that the difference, let me write it down here before I erase or move on to the next part. D is equals to 3 and A is equals to 4. Okay, let's go ahead and erase. Okay, now moving ahead to erase this part, say that A, oh, before that, we know that our general formula is equals to Tn. Okay, let me just re-establish the general formula here. The general formula is Tn is equals to 5n minus 1. So we want to find, in this case, we want to find sixth term, T6 is equals to 5 times 6 minus 1. 5 times 6 gives us 30 minus 1 gives us 29. So the next value in our pattern is 29. So I'm going to go ahead and write there as our sixth value, or rather the sixth term. Let's find the last term in this pattern. Tn is equals to, or before we've been writing Tn essentially, we need to find the seventh term. We need to write Tn because we know already found the formula, the general formula, which is Tn is equals to 5n minus 1. So now we have 5 times, we found term 6, so we actually need to find term 7. So term 7 in this case, term 7, we need to find T7, which is term 7, would be 5 times 7 minus 1. So we have 35 minus 1 gives us 34. So we can go ahead and write that value as well in the pattern. So we have 34. So which means we found 24, 29, and 34 as missing values in this linear pattern. Let's find more. Okay, that was B. Let's look at other patterns. Let's look at other patterns. That was B. Let's look at C. Now, patterns are not always linear. Some can be geometric. Rather, some can be parabolic. Okay, so let's look at others. Perhaps we might find variations in terms of these patterns. Let's look at C. Now, C. When we look at C, we are given this value. Let's see the value is given. So in this case, we have 24. It's the first value. Next value is 21. Looks like it's decreasing. We have 18. We have a missing value, we have a missing value, and we a missing value. So we need to find those missing values using the first seriation, not necessarily seriation, but the first sequence or the first precept of this pattern. Now, to do that, all we need to do, first thing that I'll want to do is to actually start identifying these terms. We have term 1, term 2, term 3, term 4, term 5, term 6. Now, the difference, looking at a common difference, we have D as to denote the common difference. D to denote the common difference is to say now term 2, same applies to this sequence as well. We have 2 minus 1 should be equals to term 3 minus term 2. D is equals to term 2 here in this case is 21 minus term 1, which is 24. Term 3 is 18 minus term 2 is 21. D, common difference, is what we want to find. In this case, you can go and punch these values in a calculator. You know that 21 minus 24 gives us negative 3. And this should be equals to, if it's not equals to this first set of values, or rather this difference, this common difference, it should be different to, it should be the same as that. If it's different, then we have to discard the notion of the sequence to be linear. So 18 subtract 21 is also negative 3. So technically what this means, D is equals to negative 3. So I'll keep that there. So I know I want to just find my A. In this case, A is equals to 24. That's our first term in the set or sequence. Okay. Now, moving on forward, we need to find the general formula for this. I have to use a different color. So the general formula, the formula that we identified earlier in the first example, A and actually moving on to B to use it, was Tn is equals to A plus n minus 1 times D. A in this case is 24, right? 24 plus open bracket n minus 1 multiplied by difference. Difference in this case is negative 3. But there are a couple of things that I like to highlight in terms of multiplication of operations. So let me actually emphasize some key conceptions with regards to multiplication of operations. Now, whenever we multiply operations, there are certain or couple of things that one needs to look at. For instance, when we multiply a negative, multiply by a negative is equals to positive. A negative multiplied by positive is equals to negative. A positive multiplied by positive is equals to positive. Positive multiplied by negative is equals to negative. This is key in terms of algebra. This is essential for our understanding of multiplying fractions, not Brexit fractions, but multiplying operations, okay, in algebra. So let's move on to actually be able to see and how these apply in this calculation. So 24, this is a constant, I'll just keep it there. So here we have negative 3 there, negative 3. Notice this negative 3. I think I'll have to emphasize this now here. This negative 3 multiplied by positive n. Negative, negative, this negative here, multiply by this positive here. In fact, I should not be doing that. Let me actually just reverse a bit. We have negative 3. This difference, the difference is negative 3 multiplied by positive n is negative 3n. Okay? Because we saw it here, there it is here. This in the second line, the second row, there it is. Okay? Negative times positive gives us negative. Even this denotes the same principle. Negative times positive gives us negative. So negative 3 multiplied by positive 1 gives us positive 3. So, and that we saw that also on our application early on there. It is the positive, negative times, in fact, this is the one. Negative times positive, negative times negative is equals to positive. So 24 minus 3n, writing it out in the right order. We know that 24 plus 3 gives us positive 27. Okay. Now let's go ahead and punch this in on our calculators to see what values we found or find as the application unfolds. So I'll have to erase this part here. Let's erase this part here. Now Tn, first devise this. Tn is equals to negative 3. I'm just continuing on here from here, plus 27. Now to find the fourth term, I just simply write T4 is equals to negative 3 times 4 plus 27. Okay, so negative 3 times 4 is equals to negative 12. There I'll just write negative 12 plus 27 is equals to, so we have negative 12 plus 27 is equals to 15. So our fourth term in this case, T4, is equals to 15. 15, and go ahead and write it down. Let's find term 5. To find term 5, all I need to do is to simply substitute. Yeah, in fact, let me reuse the same values, but just simply finding different terms. So that I'll have to erase, that I'll have to erase. This obviously is different, and the answer will be different. So to find the other values, and use a different color as well, to find the fifth term in this case, in fact, let me erase this part as well, because I need to find the fifth term. It's just a matter of substituting these values into the variables. Okay, so now to find term 4, I found term 4. Let me to find term 5. This term 4 is 15, we saw. To find term 5, I just have to write 5 there to substitute that. So negative 3 times positive 5 gives us negative 15. And negative 15 plus 27 gives us positive 12. That is for term 5. Don't forget that. This is for term 5. In fact, this is for term 5. We're just simply going to put 5 there. Now, moving on forward. So we have 12 in this case. 12 here. So now to move forward, we're gonna similarly do the same application. It looks very messy out there, so let me just devise another last application, which is now term 6. But so it's following the same rule. It will be negative 3 multiplied by 6 this time, plus 27. Okay, is equals to negative 3 times 6 gives us negative 18 plus 27. Okay, now we have negative 18 plus 27 gives us positive 9 times 6. We have term 6. So we have positive 9 as the answer, which is now our last final term. It's term 6, which is term 6. Now let's look at other more examples. Okay. Let's look at other more interesting examples. Now, so far we'll be dealing with linear patterns. Let's see other examples. Let's look at other examples. Now, let's look at D. Example D. We have values such as 2, 4, 8, 16. There's no value there. There's no value there. There's no value there. Now, to find these other missing values, what you need to do is to identify these terms first. Term 1, that's the advice I'll give in this case, because it helps with regards to knowing, or rather finding the actual position of the term. So it will be viable to actually identify the actual terms in terms of term 1, term 2, and know that you need to find other terms, which in this case is term 5, 6, and 7. So this will be term 2, term 3, term 4, term 5, 6, term 7. Now, let's go ahead and see what we find in this case for A. Now, clearly here, in this case, we don't necessarily add any value to get to the next. So the concept of common difference doesn't really apply in this case. In this case, we need to actually re-establish another application known as the ratio. Now, in this case, we need to find the ratio. To find the ratio, we just simply say term 2 divided by term 1. Okay, and we can actually even see, rather, we can have term 3 divided, just to verify and legitimize our conception, divided by term 2. R is equals to, in this case, what is term 2? Term 2 is 4 divided by term 1 is 2. It should be equals to term 3 is 8 divided by term 2, which is 4 in this case. R is equals to 4 divided by 2 gives us 2. 8 divided by 4 gives us 2. So what this essentially means, it means that the common ratio in our application is 2, which is this value here. So our ratio is 2. So now, in this case, to move forward, I need to first convince myself that I'm actually dealing with ratios, or rather a geometric pattern in this case. Now, it will be viable or valid at this case to find our first value in this case. Now a in this case is just simply 2. Now moving on forward, just to now legitimize our conception, our application is to now start saying, to prove rather, is to say T1, everyone should agree with that, T1 is equals to A, and A in this case is equals to 2. Yes, we clearly agree with that. A is there. A is our first term, and it's term 1 in this case, and it's 2. Now moving forward, term 2 is equals to A multiplied by R. So we know that R is our ratio, there it is, and A is our first term, there it is there. So let's go ahead and plug these values to see what we find. A in this case we saw that it is this value here, it is 2 multiplied by R in this case, multiplied by R is 2. So 2 times 2 gives us 4. So what this means is that term 2 is equals to 4. So let's convince ourselves this is term 2 and it's indeed 4. Now I'm going to prove that last term, the third term, to show us whether it does it. Do we really get the same value as 8? So term 3. Okay, let me just demarcate this. Term 3. We should first agree that term 3 is equals to A multiplied by R raised to the second power. Let's go ahead and plug this and see whether we get there. So 2, A in this case, we found that it was 2 multiplied by our ratio. It is 2 also. Raise this to the second power. So keep this value here. So essentially what we need to do is to first focus on the exponents. So 2 times 2 there gives us 4. Okay, and then 4 times 2 gives us 8, which is now, in this case, is claimed to be term 3. Let's go ahead and check. If you go and check, you can clearly see that there it is there. Therefore, now we can now start confirming now on the basis of observation and calculation and tests that therefore, I have to clear here now, the screen looks very messy. Okay, let's first re-establish the rule. We found that R rather, was 2, which is this value here. A is equals to 2 as well, which is this value here. So I'll just keep these because I'm going to need this kind of information. I'm going to need these parameters. So I'm going to have to erase this part here so that everyone follows. So just clear every way. I have to clear here. Okay. Clear there top as well. So use some very thin eraser. Okay, now we saw that this pattern was actually is rather linear in this case. So moving on forward, we know that our parameters, we have the R or the ratio being 2. We saw that the ratio here is 2. There it is. This is the ratio. And then our first term is 8. Now we need to find other missing values. Remember, the first term in this case was 2. Our second term was 4. Our third term was 8. Our fourth term was 16. We had missing values for term 5, term 6, and term 7. Now, to calculate, or rather find the fifth term, sixth term, and seventh term, we're going to just simply devise a formula now. To say Tn, like we did with the linear pattern, is equals to Tn is equals to A multiplied by R n to the power n minus 1. Now, in this case, let me have another application, or rather denotation on the side to actually help us understand what is that we mean by all of these variables here. Tn, this means the nth term. The nth term. The nth term. A, in this case, is the first term. This is very important to be able to identify. This is our first term. Okay. Let's look at other variables. There are many here. R is our ratio. In fact, let me use a different color, similar color, like I've done with the first two. So R is our ratio, and we found it to be 2. Okay. Let's identify what N means. N means the position. This is the position. This is the position of the term. This is very important for our analysis. So I'll leave it there for so long. Now, to move on now, we just simply need to plug in these values. A in this case, we know that A was 2 multiplied by R. So the ratio is 2 in this case. And we want to find, we don't know what the n term, what you want to find in this case, but essentially, if you want to find or substitute the nth term that you want to find, it will be 2 times 2, which is our ratio, and 6 minus 1. Let's go ahead and see what we find in this instance. So we know that okay, minus 1. Okay, let's see if I'm on par with this whole scope. I want to find the actual values of these. Okay, to find the actual value, so we're going to say, okay, we need to first establish, or rather keep the constant A as it is, and retain our R, which is 2 in this case. 6 subtract 1 gives us 5. Okay, so by multiplying this out, we get 64. We get 64. Now this term 6. In fact, we should be finding term 5. Okay, we found term 6 for now. Save. Let's write term 6. So term 6 in this case is 64. To find term 5, in fact, to find term 5, all we need to do is just to simply substitute. Just simply need to substitute there. So in substitution, we substitute a value there in this, that, and the answer as well. So now to find term 5, let me use a different color for variation. So to find term 5, we just have 5 minus 1. We know that it's 4 in this case. So 2 times 2 and raised to the 4th power. Raised to the 4th power. The answer is 32. So we've found 32 in this case. So 5th term in this case. So I can go ahead and write it down. This is 32. Now to find the last term in this case, we've just simply need to substitute. Seven, because we want to find the 7th term now. So write 7 there. 7 minus 1. 7 minus 1 gives us 6. So we have 2 times 2 raised to the 6th power in this case. So the answer is 128. So we have 128. That's our final answer for this application. Now we need to find other values. We need to find other values from other terms. So technically, what we need to do now, let's I need to clear this calculator here. States. Okay, now to find other values from other patterns, such as okay, let's look at other patterns, more interesting patterns. Now let's look at example. We just look at example D. Let's now look at example E. Let's look at example E. We have 800, 400, we have 200.
It's 21 hours.
We need to find that term, we need to find that term, we need to find that term as well. Now, essentially we need to identify all of these terms. So by identification we mean that this is now term 1, this is term 2, this is term 3, this is term 4, this is term 5, this is term 6. Now, looks like it's a geometric pattern as well. Now, we know that geometric patterns deal with ratios. So we know A is equals to term 2 divided by term 1. It should be equals to term 3 over term 2. R is equals to term 2 is equals to 400 divided by 800 is equals to term 3 is 200 divided by term 2, which is 400. Looks like our ratio in this case is just simply a half. Very important to identify this R, and rather you can keep it as a parameter in the bracket or in the box in this case. And then let's look for A. A is for our first term in this case, T1, which is 800. Very important to also identify this parameter. Now moving forward, our formula for geometric patterns follow. Tn is equals to A multiplied by our ratio raised to the power of n minus 1. Now we want to find term 4. So I'm going to simply write T4 is equals to A in this case is actually 800 multiply by our ratio is just simply a half. It's very important that I keep it in the bracket since it's a ratio, and then raised to the power of 4 minus 1. So let's go ahead and calculate this. So we have 800 minus half raised to the power of 4 minus 1. So this is actually multiplication. Okay, so we have 100. So our first answer here is 100. In fact, writing it down, I think I should actually denote that because I need to be able to be systematic. So I have 800 multiplied by a half raised to the third power in this case. So go ahead and check how much you get. If you raise that to the third power, you still get 100. So that is term 4. So that is for term 4. Let's find the value that relates to term 5. Okay, 100 from 100. Yeah, it's important that we might find that as 100 as well. Now moving on forward, we need to find now the fifth term. So I'll just simply substitute. Oops, sorry, I just need to substitute. So let's substitute this, substitute V and V and the answer as well. So because I want to find now, right now I want to find term 5, I'll have to raise it to the first power minus 1. In this case I'll be having 4 now. So now if you go ahead and punch these values as they are, you find that the answer, our fifth term, I know we're looking for the fifth term, is equals to 50. Okay, so this will be term 5 will be 50. Let's find what term 6 is. Let's find what term 6 is. So term 6, do the same application. Just substitute this value here, substitute the value here, the value here, value here, and that in the answer as well. So in this case, term 6 is going to be 6. We have 6. 6 minus 1. We have 5. And then raise that to the power of 5. We get the answer, because now we're looking at terms for term 6. In this case, we get the answer to be 25. Okay, that's our final answer for this pattern. So we get 25, this last value here. Okay. Now we need to look at a final application for the day, which is also a geometric pattern. So let's look at that pattern. So let's look at that pattern. So now in this case we have F in this case we have 1, we have 4, we have 16, we have a missing value, we have a missing value, we have a missing value. Term 1, term 2, term 3, term 4, term 5, term 6. Now, term 1, before we start with term 1, be important to actually start with the ratio. So let's start with the ratio. So in this case, we have term 2 divided by term 1. Okay, divided by term 1 is equals to term 3 divided by term 2. R is equals to term 2 is 4 divided by 1 is equals to 16 divided by 4. R is equals to 4 divided by 1 gives us 4. Okay, and then also 16 divided by 4 gives us 4, because I have a constant ratio on either side, so I can take my R to be 4 and my A to be 1. Let's move ahead and plug this into our equation. Let's divide the equation, so it's going to be Tn is equals to A multiplied by R raised to the power of n minus 1. A, found that it was 1 multiplied by 4 raised to the power of n. In this case, we'll just simply keep it as it is, as standard as it is, because we want to find term 4. So I just simply say term 4 is equals to A 1 times 4, and then our n, in this case, term we're looking for term 4, so I have 4 minus 1 multiplied by 4 raised to the third power. So in this case, we have 1 times 4 raised to the third power. The answer that we get here is 64. Okay, we have term 4, we have term 4, so our answer is 64. So here we have 64. Okay, let's look for other values. Let's look for other values. Sorry. Let's look for other values, other missing. In fact, let me actually just simply substitute here, because we just need to find the missing values. So I just simply substitute here and the answer as well. And also remember, we are looking for term 5, so this will also have to change. So in this case, we're looking for term 5. We're looking for term 5. So we have to the power of 5 minus 1. This will be raised to the 4th power this time. So if it's raised to the 4th power, we have the answer as 256. Right, so we have 256 is to term 5. 256. And lastly, to find the last term, term 6 in this case, just simply substitute 6 now instead of substituting 5 that we just had now to get 256. Right, in this case, let's go ahead and plug in those values. So we have now term 6, that's what we want to find. So I write 6, this is now raised to the 5th power. So to raise that to the 5th power, we get the answer. Remember, this is term 6. The answer is 1026. That's our final answer. So we have the answer. The answer of 1026. So that's our final answer for the day. So as we have seen, we've calculated the missing numbers in the pattern. So thank you for watching. Please share, subscribe, to my channel so that I can create more educational content